Hi everyone, and welcome to MathSux. This video is going to help you pass the Algebra Common Core Regents. We're doing this one question at a time. Here's question 36. A ball is projected up into the air from the surface of a platform to the ground below. The height of the ball above the ground in feet is modeled by the function f of t equals negative 16t squared plus 96t plus 112, where t is the time in seconds after the ball is projected. State the height of the platform in feet. So height of the platform, so what does that mean? So the height of the platform, that's basically they're asking where the ball starts from, the starting point. So if we're asking for the starting point, they really want to know what the Y-intercept is. So to get the Y-intercept, all you need to do is plug in 0 into the equation they give us. So if we go f of 0, we get negative 16. 0 squared plus 96 times 0 plus 112. So you could see right away this is going to be 0 plus 0, and then we're going to get 112. So we know that the Y-intercept is equal to 112. This is going to be the height of the platform. So height of the platform is 112 feet. There's multiple parts to this question, so here's the second part. State the coordinates of the vertex. Explain what it means in the context of the problem. So the coordinates of the vertex, so there is a formula for this. So we can start by writing and finding the axis of symmetry, which is x equals negative b over 2a. And we fill this in based on the quadratic equation they gave us. And from here we can find the values to plug into our formula. So a equals negative 16, b equals 96, and c equals 112. So now we're just going to plug this in. X equals negative b, which is negative 96 all over 2a. So 2a times negative 16. And here we're going to get negative 96 over negative 32, which just gives us 3. So this is just the x coordinate, but we're going to also need to find the y coordinate. They also ask us to explain what this means in the context of the problem. So I kind of skipped it. I'm kind of skipping ahead right here to show you the answer, and then we're going to backtrack and look at where the y coordinate comes from. The y value 256, but let's now go and see where that came from. So here we have the x value, which is 3, and then now we're going to find the y value. So there's different ways to find this. I'm going to be plugging it in to the calculator here. You could just plug it at 3 right into the equation, but you could also plug it into the y equals section. And then when you go to the table, second table, you could slide on down to 3 in the x coordinate side and just look over to what the y coordinate is that matches up with it and see that it's 256. And just to give you a picture of what it looks like graphed, what this parabola looks like graphed, we have 112 as the y-intercept. We have this little picture here, and then we have the axis of symmetry, which we found with our formula, which is x equals 3. It's always that line of symmetry where the parabola is symmetrical. And then our coordinate point that we found is 3, 256, that highest point on the parabola right there. The y value that coordinates with that axis of symmetry, that point right there. So that sums it up. And that's why after 3 seconds, the ball is 256 feet in the air. Those two coordinates correspond with each other. So now we need to state the entire interval over which the ball's height is decreasing. So if we have our picture here, 112, and then we have our parabola, and we know x equals 3. So we know that from 3 to this point, it's going to be decreasing where it's going down. So we just need to find out this interval. So we know it starts with 3, but how do we know what this value is? So this value we can actually find super easy on the calculator. So if we go to our graph, we get a nice picture here. If you have trouble getting this view, check out the window and make sure your y max is something past 256, the highest point. I have mine at 300, but you can have it at something else. So now we have our picture, and we're going to go to second calc, go to 0, and then see this little spider dude. Let's press enter above the x-axis, then go below the x-axis and press enter, and then see that this value is going to be 7. So now we know the ball is decreasing all the way from 3 to 7 seconds. And then just keeping in mind these brackets here for interval notation, we know that when we put the brackets like this, that we're including the 3 and we're including the 7 in our answer. And that's our answer. So if you're looking for more on this test, check out the playlist in the link below. And thanks for stopping by. Happy calculating. Need more practice? Check out MathSux.org for more questions. Link below. Also, don't forget to subscribe. Happy calculating!